All right, welcome to part 2 of the portals tutorial. So we're just going to continue right where we left off here. So we have it working so that we can shoot our little line trace at the wall and it will figure out where the portal should go. So now let's actually start working on our portals. So let's go into our portals folder here and let's right click, make a new blueprint class, make it type actor, call it VP underscore portal. All right, so let's open this guy up and let's just set up the viewport first and foremost. So this is really important that you do this exactly the way that I do this. Otherwise, if you have a rotation wrong or some offset wrong, it's really going to mess up the math later on. So really try to get this right. So we want to add a static mesh for our border first of all. So we'll say static mesh, and then let's call this the portal border mesh. And then in the static mesh section over here on the right, we want to select our border like so. And then we want to take this guy and we want to give it a rotation. So we want to rotate it by -90 on the Y, and that will rotate it so it's facing upright like so. And then the next thing we want to do is we want to add another static mesh. So add a static mesh here. Okay, so it by default it parented it to this guy. We don't really want that. We want everything to be parented to the default scene root. So if you just drag this guy up here, you can say attach, because you just want to have everything just under this default scene root. And then we want to select the portal wall, or sorry, not the portal wall, the portal itself, like so. And then again, for this one, we want to rotate it by -90 on the Y. Now you can see these guys are perfectly flush with one another. So if you're using your own model, make sure you have it set up this way as well. It's very important. Otherwise, you'll have a gap between them. And then let's see here. Actually, hold on. Let me look at my other project to make sure I don't mess this up. Actually, before we continue on this guy, let's go ahead and make the materials because we want to be able to set the materials while we're making these. Otherwise, we might do it incorrectly later. Yeah, so let's go back real quick. We'll come back to this guy in a second. Go into the materials folder and then go into, actually, let's make a new folder and we'll call this the portal ring. And then open this guy up. So we're going to make a material that shows around the outside of our portal. So if you remember from my other project, they have this nice glowing purple and yellow. So we're going to make that material real quick. It's pretty straightforward. So right click material, call it M underscore portal ring, and then open this guy up. So all we want to do here is hold down 3 and left click, and that will give us a constant 3 vector. And we want this to be a parameter so that we can modify it. So right click and convert to parameter, call it color. And then that's going to go into the base color. And then we also want to have this going into the emissive color, but we want to multiply it by some value so that way it's nice and shiny. So we'll say multiply and drag this into the emissive color. And then we can just drag off of this. I think you could say literal, no, constant. Yeah, just make a constant variable. And then let's set it to something like 100. And then for the color here, you can just set it to whatever you want. For right now, it doesn't really matter. I'm just going to set it to like red. And you should get this nice shiny red material. We want to hit apply and save. And then we can actually close this portal ring and come back here to our content folder. And then we want to create 2 material instances based off this material, one for the purple portal and one for the yellow portal. So right click, create material instance, call it mi for material instance underscore portal ring A. And then let's open this guy and hit this little checkbox here. And then we can set the color to whatever we want. So I'm using purple and yellow, but obviously you can use whatever colors you want. I'm going to give it a nice purple color, hit save, and then come back here again. And we can actually just duplicate this guy to create another one. Let's call it mi underscore portal ring B. And then for this one, I'm going to set it to yellow, something like that. Hit OK. All right, and we can close these guys. We don't need them anymore. The next thing we need for our portals before we can really finish setting them up is our render targets. So these are going to be used, if you don't know what render targets are, they're basically materials that you can render the scene to. So you can, draw the scene, and then instead of rendering it to the screen, you can render it to a material, and then you can put that material on something. So just to kind of explain that a little better in case you're new to this. So this, actually, let me put the yellow one up here. So the purple one is rendering the scene from the yellow one. So the yellow one up there actually has a camera on it, and it's looking down at the world, and you can actually see myself. It's looking down at the world, and it's rendering this scene, just like a game normally would render a scene to your monitor, but instead of showing it on the monitor, it just renders it to some off-screen material or some off-screen texture, and then all I'm doing is taking that off-screen texture and applying it to the inside of this purple ring here, and that's what makes it look like you're looking through a portal. Okay, so we need some render targets, so let's come back here, and let's make a new folder and call it portal render targets. And then let's open this guy up. So right click, make a new material, call it m underscore portal render target. And then also we want to create two render targets. So right click, and I believe this is under miscellaneous. No, maybe it's under materials. There we go. So materials and textures, and we want to create a render target. Actually, we're going to create two, but just select render target, and we'll call this portal render target A. And let's open this guy up. So I think in here, what did we change? I don't think we actually need to change anything. So this size X and size Y, for right now, just set it to 1920 by 1080. But this actually needs to match whatever the resolution of the game is that you're playing at. And obviously you can change the resolution, like in the settings, or like different monitors are going to show different resolutions. So we can't really hard code this. But 1920 by 1080 should be pretty good in most cases. But what we're going to end up doing is, this is what we actually need the C++ for. So there's no way to change the size X and the size Y at runtime except through using C++. So for right now, we're just going to leave it as 1920 by 1080, and things are going to look a little bit off until we add the C++ code in that will actually change it at runtime. But just so it looks pretty good for right now, let's just hard code it to 1920 by 1080. Okay, and then save that guy. And then we can close this, and then we want to make one more of these, so right click, and you can just say duplicate, and just call it same thing, but with a B at the end. Okay, so now we want to open up this guy, which is our portal render target, and we want to make use of the render target texture. So the first thing we want to do is select this guy, and we want to set the shading model to be unlit, since it's going to be used to render a render target. And then for the emissive color, we want to hook that up to a texture sample, and we want to convert this guy to a parameter, so that way we can use this for both the render target A and the render target B. And we'll just call this the render target. And the RGB is going to go into the emissive color, and then it wants a texture by default, so let's just give it, doesn't matter which one you give it, we'll just say render target A, and we should be able to apply now, and we don't get any errors. And then what we want to do is we want to use this handy little magical function. It's called screen aligned UVs. So this is kind of hard to explain what this does, but It basically makes it so that the portal, the texture, this render target, stretches to be whatever the resolution of the screen is, and that will make it look. That'll make it have that seamless effect. I can show you what it looks like once we actually get things hooked up, but it's kind of hard to explain right now since it's all just a black screen at the moment. But you just want to hook that up to there, and that's really all you need to do for this. And we can save that. And then we want to make two of these, one for um, one for the render target A and one for the render target B. So if we right click on this guy and say create material instance, we'll call this mi underscore portal render target A. And then if we open this guy up, just make sure you come up here to the right and you check this checkbox and make sure you have portal render target A selected here and hit save. And then we can just duplicate this guy again and we'll call it the same thing but with a B at the end. And then for this one, make sure you change this to portal render target B, so that way they're each rendering their own respective render targets. Okay, so now that we have all of these materials that we want, we can go back. I think now we can go back to our BP portal and finish setting this up. So coming back to the portal, the border here, we want to select in the material dropdown our m underscore portal ring. So you can just select the portal ring. I know it's going to show as red for right now, but we're going to change the actual color in the construction script. This is just so you can visualize it. And then for the static mesh, well, actually, let's rename this static mesh to portal mesh. So for this one, oh, we forgot one material. So one thing we need to do is, if you notice from my other project, if I shoot a portal at a wall, so I shoot at a wall here, and there is no other portal yet, it just shows black and like you can't walk through it. So we want to have just a nice simple black material to show by default, which I forgot to do. So let's come back here. Let's see. Let's just put it here. Just right click, make a new material. Just call it m underscore color. Actually, let's just put it in a colors folder. Let's make a new folder. Call it colors. Move this guy into here. And then open this guy up. And we're going to hold down 3 like we did before. Hook this up to the base color. Right click, convert to parameter. Just call it color. And apply and save. And so this way, I think we're going to use this for something else as well. But let's just right click, make a material instance of this for the default color. We'll call it mi underscore like dark gray. And then open this guy up. And then we'll just give it like a dark grayish color for our portal, like that. And then we can go back to our portal now, and we can set the portal mesh to be that mi underscore dark gray by default. There we go. File and save this. And then now we want to add the scene capture to our portal, because if you remember, each portal kind of captures the scene from its own point of view. So to do that, we want to add a scene capture, which is called scene capture component 2D. Make sure you do 2D. And we will call this the scene capture. And again, make sure it's not like parent or childed to this anything else. Make sure you just attach it to the default scenery up here. And you can see what that's done is it's added a camera for us. And I believe we don't need to really do anything here. I believe this is all as we want it. And so it's kind of looking out in the direction of the portal, which is correct. Okay, so I think next we can do some stuff in the construction script, because this portal is going to be looking different, obviously, if it's portal A or portal B. So let's go to the construction script here, and let's add a variable called portal A. And for portal A, we want to set it to instance editable, blueprint read only, expose on spawn, and private. So I've already kind of explained the other 3, but expose on spawn, all that does is, you'll see in a second, but when you go to actually spawn this portal, like using the spawn actor node, if you have expose on spawn checked, then this variable will show as one of the options when you're spawning the actor, which is kind of nice. So we want this to be exposed on spawn so we can specify when we're spawning the actor, whether or not it's portal A or portal B. And then we want to change how the portal looks and which materials it uses based on if it's portal A or portal B. So let's drag in portal A, Boolean, and we want to do a select here because we're going to change the material for the border. I keep saying border. We're going to say change the material for the border based on whether it's A or B. So for the border mesh, let's drag that in and say set material. And we can hook this up to here, and then we can very easily select from our dropdowns. So if it's portal A, we want to select, let's see, what did I call it? What did we call this? Oh yeah, portal ring. I guess should have called it border, but we can just do ring. Portal ring A, and then this one is going to be portal ring B. So make sure for true you have portal ring A, and for false you have portal ring B. And so that's going to change it to be either purple or yellow. So if we go to the viewport now, you can see it's yellow. And if we check portal A, it immediately turns to purple, just like that. So that's nice. And then we also want to change the texture target. So if you click on the scene capture and you search for texture target, you can see it wants you to select the texture that you want the scene capture to render to, because as it's rendering the scene, like I said, it's not going to the screen, it's going to some off-screen texture. And this is asking you, hey, which texture do you want it to go to? But we can't just select one here because it's going to change based on which portal we are. So we're going to also set that over here on the right, or in the constructor script. So drag in the scene capture and say set texture target and hook that up. And then again, we want to do another one of these selects. So drag in portal A, say get, do a select. We want this yellow one down here, and then drag this into the texture. Now this is very important. So this is actually going to be, is it? Let me think. No. So we want it to be the same. So portal A, we want to select portal render target A, and for portal B, we want to select portal render target B, for false, I mean. And compile and save this. And at this point, I think we should be able to at least spawn the portals and see it kind of working. So if we go back to our, where were we? I think we were in the portal component, which now I cannot find. Here it is, portal component. So we try add portal. Let's go back into this function here. So try add portal. This needs to actually return the portal that it spawns. So right now, we're not actually spawning a portal. We are just drawing this debug sphere. So we can get rid of this and this. And what we want to do, we still need to come back and do the other collision thing, but we'll do that later. So we're going to right click, and we'll say spawn actor from class. And then I want to select from the drop down here the portal, because that's the thing we want to spawn. And you'll notice we have this portal A checkbox, and that's because we checked expose on spawn for this variable. So that's what that does if you didn't already know. So for the spawn transform, we want to spawn it at whatever this relative portal origin is. But again, we want to convert it back to world space. So maybe I shouldn't have deleted that, but we can just redo it. So drag in the portal relative origin and say transform location. And this is going to be the get actor transform, and hook that up to, oh wait, so we need to actually right click and split this guy, hook that up to this. For the rotation, we're just going to use the rotation of ourselves. We'll say get actor rotation. And I'm just going to set this to always spawn, ignore collision, just because we definitely want this to always spawn. And then for portal A, we're just going to pass along our portal A variable that gets passed into this function. And let's go ahead and hook this guy up like so. And then there's still more we need to do, but let's just give this a try here to see if our portal actually shows up. So I'm going to press Q, And so that spawned our portal A, which has the yellow effect. And you can see it has this black interior to it. And if I press E, it spawns the yellow one. And it still has this black interior to it because we haven't actually linked the portals together yet. But we're getting close. And you should be able to do this basically as many times as you want. And they're going to just overlap with each other for right now, which isn't great. And it's going to get kind of laggy. But that's what it should be doing at this point. So whenever you press Q, it should appropriately spawn one perfectly inside of the wall. So make sure that's working. If that's working, then that's good. And we can actually start working on the portals so that they render things correctly. So let's see here. So, let's actually do this step first, because otherwise we're going to be skipping over a lot of stuff and it's going to get kind of confusing. So we want to make sure that we can't do something like this, where we have two portals on top of each other. So in order to kind of manage that, we need to keep track of the current portals that we currently have on this wall. So let's come down here to our variables, hit this plus button, and we will call this portals on wall. And we want to change the type of this to be an array, and we want to change it to be an actor array. Now you could make this an array of portals, since they are technically portals, but I'll show you why I'm not doing that in a second. I'm just going to make them actors, and we can make this private. And so what we want to do is when we spawn a new portal, we just want to add it to this array. So we'll drag in our portals on wall array and say add, and hook this guy up like so. Hook that guy up, and then let's just add a little reroute node to make it a little bit cleaner. And then we want to know when this portal gets destroyed, if it ever does get destroyed. And the only time it's going to get destroyed in this tutorial is if you were to, press Q again, and then so it would destroy the old purple portal and it would spawn a new one. So we want to know when this thing gets destroyed. So the easiest way to do that is to just bind to the onDestroyed event. So we'll say bind event to onDestroyed, like so, and hook this guy up. And then for this create event, we'll just drag off this and we'll say create event. And then we will just tell it to go ahead and create a matching function for us. And just like that, it will create a matching function for us. Except I'm going to rename this to on portal destroyed. And then we can make this guy private because nobody else needs access to it. We can also make this guy private, which I realized we forgot to do. So we might as well just do that now, since nobody else needs access to that one. All right, so back to on portal destroyed. All we really want to do here is remove it from our array. So we'll just drag in our portals on wall, say get, and then we'll say remove item, and hook up our destroyed actor. So the reason I made it an array of actors is just so I don't have to do a cast right here, because if this was an array of portal walls, then this thing comes in as an actor, and if I wanted to remove it from the array, I would then have to cast it to a portal first, which is not a big deal, but since we don't need to do that, I just figured might as well just make them actors. If you do have a need to access something that's portal specific about something in this array, then you could make an array of portals. It wouldn't hurt anything, and you would just have to do a little cast here, but I figured I'll just make it actors since we don't actually need to access anything specific about it. So now we have that, and then finally we want to return this value. So let's see, what did I return this as in my other project? I think I returned it as a portal. Yes, I did. So what I'm going to do is I'm just going to take this guy, drag it all the way back here. Oh, that's definitely not what I wanted to do. Okay, hold on. Control Z. We'll just do this manually. So let's click on this guy over here, and we'll add an output pin, and we want to change the type to be VP portal object reference, and we will call this the new portal. So this is the new portal that got spawned. Drag this over here and return this guy. Okay, so now we are doing two things. We are returning the portal that we create, but we're also keeping track of the portals. So now that we're keeping track of the portals, like I said, we can go back and write this check. So to do that, we're just going to make it a simple little function that returns a bool for whether or not this portal is overlapping with any other portals. So let's just make a function, and we'll say has room for new portal, question mark. And again, we can make this guy private. And I'm going to make this one pure and const just because it's a pretty simple function. So we want this function to take in the information about where the new portal is trying to be spawned at. So that's going to just be a y and a z value because, again, remember, we're doing all of this in this nice little relative 2D space, so we don't need to worry about the x. We only need to worry about the y and the z. So we'll add a float here and call it new portal y. So this is the y location of where the new portal is trying to be spawned. And then new portal z. And basically what we want to do at a high level here is we want to loop over all of the portals that are already on the wall. And we want to make sure that the new portal is not overlapping with that portal. So to do that, we're actually going to write a little function here just to help us out, which is going to check if two squares are overlapping with each other on a 2D plane. And I'm actually going to put that, we could just make a function over here to do that, but I'm actually going to put that in a little function library just because that's such a generic thing that I don't really feel comfortable putting it inside of something like a portal. So let's just come back here to our main content folder, and we'll make a blueprint function library. Where is this blueprint function library? This guy right here. And then let's rename this to, doesn't really matter, we'll just call it my function library. And then inside of here is where we'll write this function. And again, we're writing it inside of here just because it's so generic. It has nothing to do with portals. So if we wanted to reuse this for something else in our game, we could do it because it's inside of this nice public function library. So we'll just call it square to, actually it's more rectangle, rectangle to rectangle collision. And so we want this to take in a few values here. So the first one it's going to take in is a vector 2D, and this is going to be the rect1 origin, so the origin of rectangle 1. And then we also want to take in the extents of rectangle 1, so rect1 extents. And then we want to take in the same stuff for rectangle 2, so rect2 origin and rect2 extents. Okay, so we want to go through each of the cases of how this rectangle can be overlapping with the other one. So if you kind of think about this, I'll try to explain it real quick. But if you imagine two rectangles like on a piece of paper, actually I can just draw it because it's pretty simple. So if you have two rectangles here, so you have this rectangle and this rectangle, a really easy way to check if they're overlapping with each other is you can say, okay, is the right side of this triangle to the left of the left side of the other triangle, like in this case? And if they are, you can immediately say, okay, they're not overlapping with each other, because there's no way they can be overlapping with each other if the right side of the left triangle is further left than the left side of the right triangle. And you can apply that logic to each side of the rectangle, and if they all return, or if any of them return false, then you know that there's no way it's overlapping. So that's basically what we're going to do. So we're going to create a little sequence node here at the beginning. So to create this, you can just hold down S and left click. You can also get it by right clicking and just searching for sequence. But anyways, hook this guy up, and we're going to add 5 of these. So we want to have, well, 0 through 4, so 5. And then we're ultimately going to return true or false what for its colliding. So let's add an output parameter here and make it a Boolean, and we'll call it colliding question mark. And then if it gets all the way down to the then 4, we're going to just return true, because if it fails one of the cases before it, it's going to just return false. So we're going to go through all 4 cases for each side, like I just showed you in that drawing. So first of all, let's right click, and we're going to do the right and the left. So we'll say get get rect. I called it square in my other project because I'm stupid, but get rect. Let's see, get rect one origin, and we'll split this guy. It'll be easier once we get the first one written. And then we want to say rect one extents, and we'll split this guy. We want to check if the right side is less than the left side, so we'll do an add, and we will add the origin x to the extents x, so that will get us the right side. So I'm just going to add a little comment here. So this is rect one right, and we want to check if that is less than the rect two left. So we'll say less than. And for this part, we want to right click and say rect two origin. And we want to split this guy. And then we want to right click and say rect two extents. Split this guy. And then we want to do a subtract here because we want to get the left side. So we'll do subtract and make sure we're using the x values here and hook that up. So this is the rect two left. So if the right side of rectangle one is less than, the right side of rectangle one is less than the left side of rectangle two, then we know that they can't possibly be overlapping with each other. So we can do a branch here. Hook this guy up. And we want to just return false. So I'm just going to copy and paste this guy like so. So now we have the first case written. We can kind of just copy and paste this for the other cases. Let me just move this down a little. And we're going to want to move this over. So I'm just going to take this, copy and paste, copy and paste, and copy and paste. This would be something that would be easier to write in C++ if you know how to write C++, but trying to avoid using C++ as much as possible because most people don't know how to use it and are kind of scared of it, which is like fair enough. And then let's just hook these guys up, and then we'll modify them in a second. And this guy goes down here. All right. Pretty good. So we just want to rewrite these three cases. So let's go down to the second case here. So for this one, we want to check if the left side of rectangle one is greater than the right side of rectangle two. So instead, we want to do a subtract here. So we'll do subtract. Sorry, I had to sneeze. So x minus x, and then we want to change this to a greater than. So we'll say greater, that up. And then, so this is, let's see, this is rect one left. And then for this bottom guy here, we want to do a plus now instead. So we'll do add, put these guys together. And this is now, of course, rect two's right. And then if that is greater than that, then we want to return false again, which is good. All right, down to the next one here. So this one we want to check if the top of rectangle one is less than the bottom of rectangle two, because again, obviously if that's the case, they can't possibly be overlapping with each other. So I'm just going to change this to the y and the y, and then we're going to change this one to the y and the y. And now we have the top up here. So this is rect one top, and this is now rect two bottom, and this less than is good, so we can keep that. And then for this one, we want to change this to y and y. Well, actually, we want to do a subtract, so let's delete this guy, do a subtract here, and we want to use the y and the y. And then we want to change this to a greater than, so we'll say greater than, put that up. And then for this guy, we want to do a plus now, so we'll do add, and the y and the y, and that goes here. So this guy is, let's see, this is rect one's bottom, and this is rect 2's top. So if the rect 1's bottom is greater than the top of rectangle 2, then again, we know it's not possible that they're overlapping, so we can return false. And so if all that fails, or if all these cases fail here, then we know that it is colliding, so we can return true. Okay, so I know that was kind of a tangent, but we needed this function in order to be able to check if portals are overlapping with each other. So now we can go back. I think we got a lot of things open here. I'm going to close some of these material instances because we don't need them. Make sure if you're saving them and they ask, or if you're closing them and they ask you to save, make sure you select yes to that. Yes. Okay, so where were we? We were inside the wall, I think. BP portal wall. Yeah, so we were writing this has room. So this function we just wrote is going to be very useful now. So what we can say is we want to loop over all of these guys. So drag in our portal walls, and we'll do a for each loop like so. And then we want to check if they are overlapping with each other, but we want to do that thing where we put them into 2D space so that way we can easily do the collision checks. So I'm going to take this guy, say get actor location, so the location of the portal, and then we want to inverse transform it by the walls transform. So we'll say get actor transform, and we'll do a inverse transform location. So this will put it into this relative 2D space that we were talking about. And then we want to take the y and the z values. So we're going to split this guy, and we're going to say make vector 2D, because that's what our rectangle function that we just wrote is using. So make vector 2D out of the x and the y. And then we're going to call our square, or sorry, our rect to rect overlap, which is not showing up, or no, it's called rect to rect collision. That's what it's called. And oh, let's go into this guy. Actually, we can just leave it as non-pure, is fine. So this is going to go into our rect1 origin, because that's the new origin. And then for the extents, we're going to use our portal size thing again. So drag in our portal size, say make vector 2D, and just hook these guys up. And this is going into our extents for both of them because the portals are the same size no matter what. So let's go into the rect1 extents and the rect2 extents. And then for the rect2 origin, we want to hook that up to the new portal that's being passed in. So we'll say compile here, and we'll say get new portal y and get new portal z, and we'll say make vector 2D, hook these guys up, and hook that up to there. All right, so now it is looping through each of the portals that are already on the wall, and it's checking if the new portal will fit. And so that's what this does. We can hook this guy up like so. And then if this guy returns true, then we also want to return true. So what we're going to do here is we're going to do a branch off of this. And if it's true, then we want to return true. So let's add a little return node here. So click on this guy, add an output parameter, and make it a Boolean. And I'm just going to call it the result. And so we're going to drag this guy over here. So if at any point, oops, let me check that. So at any point, if we detect that the new one is colliding with an existing one, we want to return false right away. But if it makes it through all of them, then we want to return true. So I'm going to copy this return node, and then on the complete, we want to hook it up and return true. Okay, so now back here in our, I think it's our triad portal, where we have this to do, we can add in this function. So let's just scoot this stuff over a little bit. We can delete our to do, and we can say has room for new portal. So it wants to know the new portal y and the new portal x, which is our relative variable. So drag in the relative portal origin, right click, say split. So the y goes into the y, the z goes into the z. And for the branch, we'll make a branch here and hook that up like so. All right, so let's give this a test, make sure we did all the math correct. So we press play, we look at our wall. So I'm going to press Q, and then I'm going to look a little bit to the right and press E. So you can see it doesn't actually spawn the portal. Still pressing E, and then once I get far enough away, then it will actually spawn the portal. So now not only does it make sure it fits inside the wall, but it also makes sure that it's not overlapping with any other portal. So now if I try to spam this, no matter where I spam it, it's never going to add another portal because there's not enough room on the wall for another portal. All right, muy bien. So I think this is a good place to stop and move on to part 3 of the video. So I'll see you guys in part 3.